Hi, this is Dr. Crane, and I am here to take you on a little bit of a field trip in Moab. And I know that this is a virtual field trip, and that's not the most exciting, and that's fine. we're we're gonna get through this, and hopefully this will be a good virtual experience and a trip to somewhere a little bit more distant than Mississippi. So. Where we are is in Moab, and we are looking down to the east, down into this valley. So if you forget what direction you're oriented when you're in Google Earth, you can check your north arrow. So this little N is north. Right now, my N is off to the left. So you can think north, south. This is west, and this is east. So I'm looking, east is down the valley, west is kind of toward me sitting at my computer, over here is to the south, and over here is to the north. You should have your Fieldcamp folder loaded in Google Earth for your structure portion of Fieldcamp. It'll have all the formations in it that we'll be dealing with in this structure session. They'll have our 3 field trip stops, and it'll also have the cross-section lines you'll be working with and the geologic map. So just a note about the geologic map, you can click it on and off. It should be draped across the topography. If to you this area looks very flat, it's because you don't have your terrain turned on. So you'll want to go down here to terrain and click terrain from off to on. Now your terrain may look like this. It might be really kind of red to pink. And so to fix that, what you're going to do is you're going to go up to this little stopwatch looking icon that has a green arrow going back. That allows you to access different dates and imagery through time. Now there's nothing wrong with looking at this data set. But do you see how it's kind of choppy right here? How you might get one idea of what a formation looks like in this set of images and then a different idea in this set. So the way that you can fix that is just to open that icon up, and yours would probably start here. So this data was collected in May of 2016. You'll just click the forward arrow until you get to this most recent data set, 8/2019, and it's a little less red than what you might think it would be, but that's fine. It looks like a unified data set, and that is going to be better for what we're working with doing this virtual fieldwork. Now hopefully you've already had a chance to look at all the different formations, and what I mean by that is that each of the formations I've marked with one of these little white icons. So if you go navigate to one of those icons, for example, JN Navajo Sandstone, what this means is that JN is the formation abbreviation used by the USGS, and then the formal name for that unit is the Navajo Sandstone, or whatever unit you're going to look at. If you take the little orange dude, you can put them down by that icon. The blue road means that there's street view available, so I'm actually going to drag this to the nearest street view. And that icon had been over here. So this is going to give me an idea of what the Navajo Sandstone looks like in the field. This is the Navajo. This unit up here is called the Entrada Sandstone, and that's another unit that you'll visit with the small icons. But this is the Navajo. And so when you are working through the strat column that you're going to make, what I want you to do is definitely list the abbreviation for the unit, list the name, and then give it your own description. Now you'll notice for each of these formations, so let's go to Navajo Sandstone. You'll notice for each of these, and I just added north side of the road so that you knew to look this way, but I've copied the USGS description of that unit. So pale orange, light gray, red orange, fine-grained quartz, aeolian sandstone, calcareous, and silica cemented. And you can keep reading that. Sweeping cross beds, and let's see, forms vertical smooth cliffs and rounded knolls. These would be those rounded knolls. So this is gonna be a really big description, and in some ways you're not going to be able to match that detail because we're doing this virtually. So for example, I'm not going to expect you to know without reading this that this is fine-grained, and certainly virtually you won't be able to use that it's fine-grained to help you identify this rock unit in other parts of the field. But you can use this color. You might want to put down that it does have massive, medium to massive bedding, that it can be large scale. The sweeping cross beds might show up if we moved up and down the road, which I definitely suggest doing. And then those knolls. And the color is just really light compared to the units around it. For me, I would also note that it's below the entrada because it contrasts so sharply, and because this unit seems to be like a nice orangey red cliff former. If I know that I go right below that and I see this type of sweeping, lumpy, tan unit, that's the Navajo Sandstone. And here we might be able to actually see some of those cross beds. So when you do your strat column, you'll have gone through and done that for each of those units and put them in order by age. And once you've done that, then you're ready to start field trip number 1, or field trip stop number 1. So if you want, you can pause this video now and do that, or if you've already done that, go ahead and keep going. I'm going to exit Street View. Okay, so again, you're going to do that for each of the white markers that's associated with this structure activity. Okay. Boop. There's probably less motion sickness associated with real field trips, you might think, but actually driving in the car here, you might get sick too, so it's fine. Okay. So one of the reasons why I brought you all here, one of the reasons why I brought you all here is that one, the units are pretty identifiable. So for example, if you look up here to the right, see how that's like a light top and it looks kind of fractured? That's the Wingate Formation, this one right here, JK. And so that's, that's like a not easy to identify, but it's certainly distinct from the other units we just saw. So the units here are pretty distinct. The other reason we're here is that there's a major fault in this region. And if you are just starting out in geology, you might not look at this particular terrain and be like, oh yeah, of course there's a fault. So I want to explain to you for a second how maybe a more experienced geologist would look at this and maybe not know it's a fault right away, but know something's up with this. Okay, so here would be my first clue that something's going on. Okay, if you look to the right, if you look over here, these units are, they look regular. Kind of like, well, if this way is to the east, they look like they're dipping to the south. They're all kind of following this top, and they're very regular, for lack of a better way to explain it. I'm going to drop down into Street View and see if I can explain it a little better down here. Okay. Up here, this is actually, it's called the Wingate Formation. So we've got a nice dip to the south, and over here, it looks like rubble. So we have a valley, and we have rocks on both sides of the valley that look extremely different. Let's go a little bit farther down. Okay, so we've got a nice cliff former, a slope, dipping this way. Over here, just something different is going on. And a different rock type. Like, clearly if I went straight across or I tried to correlate these over, this rock is not the same as this rock. So that should be your first hint that somehow going down through this road, there's some kind of a structure. Okay. Let's exit Street View. I mean, these units, it's almost hard to figure out which way they're dipping. They look like they're almost dipping toward the south, like they're on-lapping onto this slope. So that's kind of your first hint that something's weird going on. Okay, let's go ahead and go down to our field trip location. I'm having a hard time finding this. Okay. So field trip stop 1, I'm going to drag and drop into here. Over here, if we look back this way, again, that's the Navajo Sandstone. That's the entrada on top of that. And if we look back this way, we've got some structure. Okay. So, what I'd like you to do with this outcrop, the first thing you're going to do is sketch it. So let's think about what direction we're facing right now. I'm going to exit this really quick. Okay. Field trip stop 1, we are facing this way, right? We're facing this big block of rock. The visitor center is behind us. Okay. North is back here. So that means that this way on the outcrop to the left, this is east. And over here, this is west. So as you do your sketch, you're going to have east and west. Now you can also see in Google Earth that there's a truck right here. So we're going to drag and drop to that truck and help us get an idea of scale. All right. See if there's any other cars. Oh, there's a nice minivan. So what I want you to do is you may not be able to exactly tell scale in these pictures, but if we go down to this minivan, maybe that's a Mini Coupe, oh no, there's the minivan. Okay. Your first assignment at this outcrop is going to be to sketch an area of the outcrop. And you're going to use your minivan for scale. And again, you're going to remember that east is on your left, west is on your right. So full credit sketches will have a scale, they'll have an orientation, and they'll highlight the important structures. They'll also describe the rock units. Okay. Now this rock unit in this particular outcrop is not one that's labeled on your map. And the reason for that is that it was hard for me to find an outcrop where it's exposed at the surface. So this is actually your chance to see that particular rock unit. I am pretty sure that this is the Cutler Formation. It is a lower Permian formation. That's its age, is lower Permian. And it's a red to purple sandstone. You can use the USGS map that's provided with this activity to learn a little bit more about it. But when I was, when I was looking at this, I was seeing these purples and kind of red to orange rocks, and particularly the purple one, stood out that I really haven't seen purple too many other places in this outcrop. Below this unit, and I say below, stratigraphically below. So if we trace this red unit across, we can go below the red unit. Below that red unit, we start to pick up on this gray type unit. That gray is called the Honaker Trail, Honaker, Honaker Trail, which is Upper Pennsylvanian, and this is above the Paradox Formation. So the Paradox Formation is the lowest formation, or the deepest formation that we'll be working with, the oldest one. And then above that would be this Honaker Trail, which is gray gypsum and light gray to grayish pink sandstones, limestones, and siltstones. And you can use the USGS again to learn more about that formation. So we've got Honaker Trail above the Paradox, and then we've got the Cutler, which is above the Honaker Trail. These are really old formations. Okay. Once you have sketched this, what I'd like for you to do is think about the possible orientations of the faults. How are they striking? How are they dipping? And obviously, you're not going to be able to take a strike and dip, but label in your sketch this fault, for example, it's dipping down and to the west, like southwest. Okay, so this purple unit has dropped down. We can also estimate the meters here of displacement, of the amount of movement along the fault, because we can see this minivan. So if we just estimate that this minivan is 5 feet tall, okay, and we kind of translate it up here, then we might have 4 or 5 feet of displacement from the top of this purple marker point to the top of this purple marker point. That's how we would tell the offset on that fault. Okay, so you'll label your scale, orientation, label your structures with the direction of slip on them, and you'll describe those units that are in there. Once you've done that, what I want you to do on this outcrop is calculate the amount of linear strain. So if you remember, stress is a force per unit area that's applied to a rock and deforms that rock unit, and strain is that deformation. It's a quantitative estimate of that deformation that compares the deformed rock to how it was before. So if we're going to calculate strain, we use the formula a change in length over the original length. So we can also say that that's the new length minus the old length divided by the old length. Okay, so this new length, if we think about the types of faults that are shown here, these normal faults, this new length is longer than the old length. So here's what I mean by that. If I put a marker right here, if I hold my mouse on this part of the purple outcrop, and I measure all along here, that length, then I come down here and I measure from right here all the way over. This length and this length added together are the original length. But this block of rock has slid down, it's slid away from kind of its partner piece over here. So there's been extension. The new length is here to here. It's that horizontal distance. The old length, or the original length, is here to here, I think, or maybe here to here. You'll have to spend some time looking at it. And here to here added together. So what I want you to do on this outcrop, and everyone's going to have a little bit of a different answer, is I want you to try and estimate strain. And again, you can use the minivans in this picture to help you estimate strain. If you want, you can start all the way back here and go across the outcrop. I actually recommend doing that. So pick a unit that you feel like you can see all the way across. So for me, it's probably going to be that purple unit. I can pick up the purple unit right here. I would start right there. Another way that you can measure that length is you can decide to add points or to draw a line. And I think we can draw a line in Street View. Maybe not though. No, we can put points down in Street View. So I'm going to put a point down here, for example, and I could call this my start. And it's the start of my purple unit. If you exit Street View, that start point should be right there. Okay? And then I'm going to come down and figure out my ending point. I'm going to end right here. This is the last spot I can see it. So I'm going to stand, it's virtual. I'm going to stand across from that point, or across from that spot, which is the last purple spot I see, and I'm going to put a marker right across from that. End. If I exit Street View now, I can measure the distance between these two. So I'm going to go to my ruler tool, line, and I'm going to not measure it in inches. I'm going to measure it in kilometers. Start to end, 0.11 kilometers. That is my new length. Okay, so now what you're going to have to do is you're going to have to go back into Street View. And you're going to have to estimate the length of each of these sections using these cars. Give yourself some patience. Your answers are not going to be perfect. I just want you to get an idea of extension and start practice calculating some strain percentages or strain estimates. You can express your answer as a percentage or as a decimal. Again, I'll have all of these directions typed and provided separately, but I thought you might just want some time together at this outcrop. So themes on older rocks, or what I've noticed, are that the older rock units seem to be more grays, purples. There's more variation in color. And the younger rock units, I saw them as being more of your standard tans and reds. So I'm going to keep a lookout for purples, grays, things that are a little bit blockier as we move through this exercise, and you guys should too. All right. Bye.